Come talk to me about this later. Let's see, is it working? So far,
video quality.
7.1, I think it's working, y'all. Right? Okay. Alright. Thank you, Taylor.
You're welcome.
Alright, so we are graphing. This whole chapter is called Graphing Systems of Equations. That's what we're going to be doing. Graphing Systems of Equations. 7.1 deals with solving a system by graphing. I know you're like, how is that different? Okay, so we're going to solve a system, and I'll explain what that means, and we're going to solve it by graphing. Okay, step 1, we are going to graph both equations on the same coordinate plane. So basically, you're going to take the two equations and you're going to graph them. Make sure you put them y equals mx plus b format. Taylor? It's okay. Remember, we ignore. They're little bitty kids. Okay, so graph both equations on the same coordinate plane. Step 2. You're going to identify the solution. Now, the solution is really considered the answer. What it is the coordinates of the point of intersection the ordered pair. It's the point of intersection, your ordered pair, your x and your y. Okay, so the solution is your point of intersection. You're going to graph the two equations, and I don't have one up here. Where they cross, where they meet, that ordered pair, that's your answer. So the solution is really kind of like your answer. It's going to be in the form of an ordered pair, your x and your y. So again, you're going to graph both equations on your coordinate plane. So you're going to need graph paper and your rulers, and I'll get, Olivia, I'll get you a ruler. I've got plenty of extras. Then where they cross, that point of intersection, that is your solution or your answer. It's going to be in the form of an ordered pair. Okay, most of my students, if you really get graphing, once you see what we do tomorrow and everything, you'll understand why a lot of students like this method. It takes up less space. You don't spend, paper. It's just a no-brainer. The problem is that if your book says solve by graphing, then you're going to have a perfect ordered pair. -4, and 3, or something like that, whole numbers. If you're meant to do it by substitution or elimination, which we'll talk about later, and you say, well, I don't like those, I want to get the answer by graphing, it may not cross in a perfect place. It's going to be like 5.6892, comma, -0.5. So, you know what I'm saying? It's going to be weird places on your graph. So if your book tells you to solve by graphing, do it by graphing. If it says by substitution, even on your test, you need to do it by substitution because it may not work as neatly as with graphing. Does that make sense? We're all getting the same solution, an order pair basically. You can get it by graphing, which is what you're learning today. Tomorrow is going to be by substitution. You know, and there's different methods of getting it. But your book has designed certain problems to work better for certain methods. Okay, so then I'm going to add to this, and I'm repeating myself on here, but you know how I am. I write it multiple ways so you get the idea. I'm driving it home. The solution is, yes, I'm repeating myself, the point of intersection of both lines. And the point of intersection is where the two lines meet across. So I'm just kind of re-explaining it for that. And then the last part, number 3, you can check the solution, that point of intersection by substituting it into each equation. I'll show you how to do that. Oops. Go back a little bit. Okay. When you're done, put your pencil down so I know that you're done. We'll see how far we get today. Okay. All right, example. You're going to need to go to the back of that paper. We're going to do our first example. Once I do this example, it'll bring it all home and you'll say, oh, that's what we're doing. Okay, gotcha. We're going to solve the system by graphing. Okay, so let's say line 1 is x minus y equals -5. In line 2 is 3x plus y equals negative 7. So there's our two lines, okay? Or our two equations. Line 1, that's that equation. Line 2, there's that equation. Remember that you are looking for the point where these two lines cross. So we're looking for where those two lines cross. Answer, I'll let y'all catch up, will be an ordered pair once you have this all written down, you may put your pencil down so I know that you're done. Okay. So, to be able to graph these, what do we have to do to them? Raise your hand. Aiden? Yep. We're going to have to turn all of that into y equals mx plus b format. Okay, so let's get started doing that. So line 1, make sure I don't cut it off. It is x minus y equals negative 5. So line 1 is x minus y equals negative 5. Line 2 is 3x plus y equals negative 7. Okay, so I took these two equations, I rewrote them right here. When you do your homework, you're not going to have all this stuff, so this is just for notes. So we've got our two lines written here. Now we isolate the variable. We have to rearrange all of this to put it into this format, right? Okay, so Michael, let's start with line 1. You tell me what to do. What do I move first? That's right. We're going to subtract the x on both sides because we're doing the opposite. This is positive, that's negative. And I'm left with negative y. Don't forget that negative sign equals negative x minus 5. Now what do?
You multiply negative 1.
By everything. Because can we have a negative y here? No. So I have y equals what?
Y is equal to x plus 5.
Plus 5. There we go. We have our line 1 in the correct format. Perfect. Any questions where he got all of that? Okay, so you can't have the negative, so this becomes positive and that becomes positive, right? Okay. So let's see, Emily, my next victim. Help me with this one. Change it around. Subtracting 3x on both sides. That crosses out. I'm left with y equals negative 3x minus 7. So line 2 is done. It's in the correct format. We know our slope now, we know our y-intercept, etc., etc. Let's pull this up. Any questions so far? Alright, so now we're going to graph. It doesn't have to be perfectly neat on your notes. It does have to be on graph paper in your homework. Okay, so I'm going to go ahead and I'm going to draw, just because I can't, gotta have something. And y'all can too. I'm not saying you can't go grab your rulers, but. Here's my Cartesian plane. Here's my X, my Y. So, Taylor, for line 1, what is my slope?
1.
1. Or you can say 1 over 1, right?
Mm-hmm.
Cecilia, what's my y-intercept? 5. Very good. Okay? Cecilia, what is the first thing I do for this? Do I do my slope or do I do my y-intercept? There you go. Okay, so for line 2, Aiden, what is my slope? I'll say negative 3 over 1. And then our y-intercept is what width?
-7.
Very good. Okay, so let's start with this one first. We have positive 5 is my y. 1, 2, 3, 4, 5. And then my slope is 1 over 1. So 1 over 1, we can go down 1 over 1. So then you have what on your pages should be similar to a straight line. Again, on graph paper, it's going to be more perfect. So there's my first line, line 1. Line 2, y'all go ahead and graph it. The y-intercept is negative 7, so be careful. Y'all have 2 weeks of vacation. Negative 7 is going down. 1, 2, 3, 4, 5, 6, 7. First dot. And my slope is negative 3 over 1. So down 3, 1, 2, 3, and then over 1. Right there. Or we can go up 3, 1, 2, 3, and in this direction for 1. Unless you've got now, I will tell you, you remember me telling you that you should do as many dots as possible? Now, before chapter 6 and 5 and everything, 2 dots is all you needed. For this stuff, I would do, especially for when you're supposed to be using graph paper, I would do 1, 2, 3 over 1, as many as possible. This is terrible. I need graph paper. Okay. Now, since we're not using graph paper, you have no idea where they're intersecting. Okay? If we were using graph paper, you would. So the answer is right here, where they intersect. That is your answer. That is your solution. Oh, that's a terrible arrow. Okay. That's your solution, the point of intersection. Do y'all see what I'm talking about now? So you don't just graph these and circle it. You actually have to give me the order pair. Now, on regular paper, we are going to be guessing, okay? I'm going to tell you what it is, But when you do it properly on graph paper, it's going to be clear. Now, guys, in all seriousness, if you are graphing it perfectly perfectly well, you're doing it correctly, and you need to do more than just 2 points. You need to do 3 or more to make it real accurate. You know what I'm saying? If you have some weird point of intersection that it's not like obvious, it's not weird looking or something, then you've done something wrong. Okay, it's got to be, it's going to work for you. If it didn't work, or if your lines are never cross, you have done something wrong. You see what I'm saying? That's how you can check yourself. Okay, so this would have been, if we had done on graph paper, -3, 1, 2, 3, and then +2, if we had done it on graph paper. So this, boys and girls, is your answer. This is your solution. Does that make sense, what you're doing today? Any questions so far? All you're doing is graphing, and then wherever they cross, that's your answer. Put it in and don't circle it and say, there's my answer. No, you're going to put it in ordered pair. Does that make sense? Okay. Everyone have this down? So you got it? Okay. Now I'm about to throw a little wrench into all of this. Everyone's like, okay, I got it. I can do this. However,
Not anymore.
not anymore. Again, we're going to solve systems by graphing. Same directions as the last one. Line 1, x plus y equals 3. In line 2, 2y equals -2x plus 6. Whoops. Okay, so line 1 is x plus y equals 3. Line 2 is 2y equals -2x plus 6. So write that down. Okay, let's start putting these into y equals mx plus b format. Gabby, tell me how to put this into y equals mx plus b format.
You're going to subtract x from both sides.
And I get y equals -x plus 3. Okay, there's my first line. That's perfect. Aiden, tell me how to put this one into y equals mx plus b.
Divide the x and the b by 2.
So we're going to divide everything over here by 2 because we got to get rid of that 2. And since the 2 and the y are multiplying, the opposite's dividing. So we're dividing everything by 2. So then I get y equals -2 divided by 2 is? So -1x plus what? 3. Alright, I want y'all to look at these two. We saw them, right? Line 1, line 2. Raise your hand if you notice something about them. What?
They're the same thing.
Guys, look at these. They are the same. I mean, there's no 1 here, but we know that we assume that's a 1, right? So, are they the same? So, you know what that means? They're what? If the equations are the same, then they're the same what? The same line. Will they ever intersect if they're the same line? So these are the same line.
Is that the answer?
No, that's where I'm going with this. So look at the original equations. X plus y equals 3 and 2y equals negative 2x plus 6. Who would have ever thought they're the exact same line? If I were to graph these two, they're the same line. So if the solution is the point of intersection where the two lines cross, if they're the same line, they kind of cross on all points, right? So your answer,
Water.
no, you rewrite the equation. Because, remember, the solution is the point of intersection. The point of intersection where they cross is an ordered pair, the x and y. But if the two lines cross literally on top of each other at every point, then that's your answer, the line. So you're not going to be able to just look at it and know which are the same lines, which are not. You're going to have to literally put them in y equals mx plus b, then look at it. Now, I'm going to tell you, I have students that will legit get to this point, and then instead of looking at the fact that they're the same line, they'll start graphing. And then it's after that they draw their Cartesian plane and start they'll even put, I've seen this every year, they'll say slope is -1, slope is -1, y-intercept is 3, and it still doesn't click. It's the same line. So you're done, you only have to graph. So if it's the same equation, your answer is that equation. That's your answer. Does that make sense?
Well, you get it wrong if you put a 1 there.
Nope. If you want to put -1x plus 3, that is okay. It's the same, I won't say or. That's the same thing. We assume there's a 1 right here. If there's no number with the variable, then we assume there's a 1. If you put that, it's the same thing. So, there's no point of intersection the entire line is the intersection. Make sense? And these are my little weird stars. The what, Taylor?
So that one's right.
Oh, I've got another one. When you're done writing that, put your pencil down. You good, Taylor? Okay. All right, so I'm turning the page because I don't want to squish anything up. If you have less than half a page left, I would turn the page. We're going to do another example. Same thing as before. I'm not going to write the directions. Y'all get it. We're solving the system by graphing. Okay? Let's say this time line 1 is x plus y equals 3. And line 2 is x plus y equals 7. Okay, Okay, so we have line 1 is x plus y equals 3, and line 2 is x plus y equals 7. Whit, let's go ahead and put these in y equals mx plus b format first, just to see what's going on here. You can do line 1.
You're gonna subtract the x on both sides.
And what do you get?
Y equals negative x plus 3.
Alright, so we have line 1. Michael, do line 2.
You subtract x on both sides. And it would be y minus x.
Equals,
Y equals negative x minus 3. Wait, minus 7. Plus 7.
which is it?
Plus 7.
Okay, there you go. Okay. Emily, I want you to sit back and observe these two lines. Tell me what you see. I said Emily Taylor. What do you notice? Are they the same exact line? Okay, but are they the same exact line? No, because their y-intercepts are different, right? But what do you notice? What do they have in common? Okay, so what is that called? Is it our slope or our y-intercept? What's your y-intercept? Bingo. So then what is the negative x? Your slope. So note what is the slope for line 1? Emily?
Negative x. Oh, sorry.
No!
Line 1!
What?
oh.
Okay, no, you're right, this is the slope, but do we say negative x is the slope?
Negative.
There you go, negative 1. Emily, what's the slope for this line?
Negative 1.
Okay, guys, now think back before Christmas. Raise your hand. If you can remember, if two lines are not the same line, but have the exact same slope, Taylor, what are they?
Parallel.
Parallel lines. These, boys and girls, have the same slope. And, that's my and, different y-intercept. Exclamation mark, exclamation mark. They are parallel lines. That's my little star. So that's why, again, you need to put them into the y equals mx plus b format, slope-intercept form. So up here. And then you can look at it. If they're completely different lines, graph it, get the ordered pair where they intersect. If they're the exact same line, then your answer is going to be that equation. You got it. That's why your notes need to be nice and neat. You got to remember what to do in each of these cases. If the slopes are the same, but you have a different y-intercept, then they're parallel lines. Now, if you tell me, if you do this, and you say, well, the slopes are the same, so they must be parallel. Well, no, because they have the exact same y-intercept. Do you see what I'm saying? Be careful. I've had kids tell me that. No, same slope, different y-intercept. So the answer, the solution, is there. No solution. In fact, how does your book make you write? Yeah, just like that. No? Yeah. basically no solution. If they're parallel lines, are they ever going to have a point of intersection?
No.
No.
You draw it then.
Exactly. No point of intersection. And so since we are looking for that point of intersection, because that's our answer, if they're parallel and they never have a point of intersection, then it's no solution. Does that make sense? Okay, so that's what y'all are doing. That's it. I mean, literally, that's it. And so the first one, plain and simple. You put it in y equals mx plus b, graph it where that point of intersection is, that is your answer, written as an ordered pair. If you put them in y equals mx plus b and they're the exact same line, then your answer is going to be that line, that equation, in that form. If the slopes are the same, y-intercepts are different, and they're parallel, then it's no solution, and that's your answer. Questions? Alright, does everyone have that? Okay, so let's open page 281 for examples. And, Olivia, don't worry, we'll get you that book, don't worry. And right now, I'll just let y'all can move your desks together a little bit and look at it. Okay. So let's start with number 1. Let me make sure everyone's got their book open. Okay, number 1. It says, identify the solution to each system from its graph. If the solution is a line, state the line's equation. Okay? If it doesn't have a solution, then you know what you got. I mean, if it doesn't cross or have point of intersection, you know what you're supposed to do. So again, we're looking for the solution. The solution is that point of intersection. So number 1, that graph. Cecilia, do those two lines cross? Okay, what is the ordered pair that represents the point of intersection? You know, give me that X and Y of where they cross.
Y is 5, X is 1.
Okay, but we write it as 1 and 5. Remember, X comes first and then Y, or you're going to get all kinds of stuff. So yes, that is your answer right there. So Olivia, you can write that down, then when I make the copy and everything, you'll have that for you. Okay? All right. Any questions on number 1? I hope everyone understands what she did. Okay. 3. Aiden.
The lines are parallel.
So then what's your answer?
There would be no solution.
No solution. Very good. The lines are parallel, they never cross, so the answer is no solution. All right, now let's look at 5. Okay, determine whether -2 and 5 is a solution to each system. Okay, the reason I didn't check on the examples we did is because I knew we'd be doing this example. So they're saying, is -2 and 5 a solution to those, to each system? So they give you x plus y equals 3, and 2x plus y equals 1. And they're asking if, do you see the directions, by the way, the negative 2 and 5? Are y'all reading the directions with me? Okay. They're asking if this is a solution in each of these systems. So guess what we're going to do? We're going to substitute. This is line 1. This is my x and my y. We're going to be subbing the x and the y here and here. So I'm going to have now negative 2 plus 5 equals 3. Remember, this is line 1. So then, negative 2 plus 5, does that equal 3? What?
Yes, sir.
That's right. So negative 2 plus 5 is 3. 3 equals 3, so check. It works. So now let's do line 2. So I've got 2x plus y equals 1. And I'm going to substitute the x and the y. And remember, I got this ordered pair from the actual directions. They said, is this a solution to these two systems? I'm going to substitute this ordered pair, the x and the y, in line 2 now. So that is 2 times x, right? So 2 times negative 2 plus 5. So, Gabby, what is 2 times negative 2?
Negative 4.
Plus 5 equals 1. And, Gabby, negative 4 plus 5 is? Positive 1. Did I say negative 1? Okay, I could have said anything. So, is this a solution to this system? Yes. So, it works on both, so the answer is yes. That ordered pair that they gave us in the directions is in fact a solution to each of these systems. System is just another word for equation. So this is the answer. It works in both. Check, check. Answer is yes. Any questions? Are y'all getting this so far? Not too bad, right? All right, I'm going to do one more example. Everyone ready? Because I think this is not too bad. Number 15. It says solve each system by graphing. They give us y equals negative x plus 5. Hold on just a second. Y equals x minus 1. I'll have you guys work it out like we did in the examples, and then we'll see if y'all get it right. So y'all work it out. I have this, the little one. I need a big one. And you don't have one in your closet? That's fine.
Oh, you did have it now. Because I already didn't order them come in. If I'd have known, it was in my
I know. But,
Okay.
so I can make, she's sharing with Gabby,
Okay.
and I'm just making.
Can you share them with me?
No, that's, I even asked kids, I said, no, you don't have it. I don't have it. I have the extra Z's.
Okay.
So, right. Now, don't put a rush or anything on it. It's real easy to just make a copy of Gabby's stuff.
Okay.
So just whenever it comes
So I
in.
do it 7 days instead of the 2 days?
Yeah, don't even worry about it. Real quick question, are these two lines already in y equals mx plus b format?
Yeah.
Yes, they are. So we can go ahead and solve these. What is the slope for this first line? What?
-1/1.
And what is the y-intercept? What?
5.
Okay. Michael, what is the slope for the second line?
Oh,
Positive 101. And what's the y-intercept for the second line?
-1.
Yep. Okay, so they're ready to be graphed already. You didn't have to rearrange these or anything. And I know you probably, I'm going to graph it because you're probably looking at your regular paper like, man, I don't know if this is right or not because you're not using graph paper right now. So I'm going to graph mine and see if your graph looks anything like mine, then you're on the right track. And, you know, once we start working, you'll have the graph paper and you'll get it. Okay, so this one, we have positive 5, so let's add it 1, 2, 3, 4, 5. And it's negative 1/1. I'm going to try to space these out perfectly, but you know it won't be. Okay, so negative 1, and then 1, 1 and 1. 1 and 1. Okay, so I got that one. And remember I said do as many points as possible. And then this next one is negative 1. It's y-intercept. And then we have positive 1, 1. Positive 1, 1. Think you see where this is going. Hopefully yours looks like this. So right here is our point of intersection. Your answer would be 3 and 2. If you got something similar, like, okay, I'm on the right track, I know what I'm doing, it's because we're using lined paper that I didn't get it perfect, you're good to go. Any questions? None? Okay, good. We're going to stop there. No homework, no independent work, nothing. We're easing our way into it. You only have 2 minutes left of class anyway. So then we're done with notes. Tomorrow when you walk in, I'll go over the notes again and I'll let y'all get started. Okay? Alright, so I'm going to stop this.